Hello everyone. In this lecture we'll see inverse differential operator and the particular integral. Under this we'll see how the non-homogeneous differential equations are going to be solved here. So here in this inverse differential operator and what is the particular integral, we'll see in detail. So already we know that. So we have the differential operator. The differential operator, that is d is equal to d by dx. So this is a differential operator we have already seen. So what is inverse differential operator, that part we'll see now. So let us suppose that d is a function of g of x. So here d is a differential operator, remember. So d is a differentiation of g of x is equal to, I am writing what here, some result f of x. So to get a inverse differential operator, so integrate on both sides. So on integration, this is a differential operator. So on integration, differentiation will vanish. So therefore what we are going to left here, g of x in the left hand side, but right hand side integration of f of x into dx. So here why d went here? So d is nothing but what here, d by dx. So integration of d by dx with respect to x is always the given function. The given function is g of x. So integration of f of x dx. So therefore, so I can equivalently write it as means cross multiply, or equivalently the same thing we can write it as 1 by d times function f of x into dx is equal to g of x. The above same expression notationally 1 by d means 1 by d is nothing but integration symbol. So instead of writing the symbol integration, I am writing 1 by d of f of x dx is equal to this g of x. So here I can say that the operator 1 by d that stands for the integral is called an inverse differential operator. So 1 upon d stand for what here? Inverse differential operator. So this is 1 upon d. You have to remember, this is 1 upon d, inverse differential operator. So similarly, so 1 upon d is nothing but one time integration. So similarly I can say that 1 upon d square is nothing but what here, 2 times integration. 1 upon d cube is nothing but 3 time integration. So I can say that etc. stands for successive integration. So 1 by d is nothing but one time integration, but 1 upon d square is 2 time double integration. 1 upon d cube is nothing but triple integration. So these are things. So double integration, triple integration already you have seen in the first semester. Okay. So that situation, if you find 1 by d square, so remember that you are going to go for what here, double integration. If 1 upon d cube comes, we are going for what here, triple integration. So these are the things we need to remember for our this inverse differential operator concept here. Now again, so to see the particular integral, we'll see what your particular that is, in short, it is pi or yp. So we know that our equation will be f of d of y is equal to, we'll get here phi of x, which is nothing but what here, non-homogeneous differential equation. So for the left hand side, so we'll get yc, but for the right hand side we are going to get a particular integral. Already we have discussed this case, so I can say that if f of d of y is equal to phi of x, then y is equal to yp of x, which is free from what here, free from the arbitrary function, free from the arbitrary constants, better, arbitrary constants, is the particular solution, or we call it is particular integral, or particular integral. So therefore, to get a particular integral, so what we have to do here, so keep y here and shift this f of d to the right hand side, it will become phi of x upon f of d. So therefore pi or yp is nothing but phi of x divided by f of d. So phi of x, what right hand side function they will give, and f of d is nothing but auxiliary equation, and we need to simplify. But this phi of x having different kinds of forms, so that different kinds of forms, usually we have 5 specific forms here, like e to the power any function, that is e raised to in general e raised to ax form, or phi of x may be trigonometric function like sine x or cos x. Then we may have what here other forms also, like tan also will come. Then this phi of x may be this one, what we can say, polynomials and all. So for those things we call it is the different kinds of types to get a particular integrals. So for our syllabus we have 3 types. Maybe type number 1 belongs to what here, e to the any function, e to the power any function. Then type 2 belongs to either sine of the angle or cos of the angle, and type 3 belongs to what here, phi of x may take what here, polynomial divided by this arbitrary auxiliary equations. So we'll see that details like type 1, type 2 and type 3 in our next classes. So these are the way. So to get a general solution, so to get general solution of this non-homogeneous differential equation, so y is equal to yc plus yp. So you know that yc, so how to get yc, the same procedure we need to follow here, but to get yp we need to use this concept here. So in this way we need to generate a general solution. With the help of yc and yp we can conclude for the general solution for the case non-homogeneous differential equations.